Welcome to the System Design Framework channel, where we simplify complex system designs and turn them into easy-to-follow step-by-step guides. In the previous video, we dove into architecture selection for building a social media platform, where we discussed how different architectural decisions, like whether to go with monoliths or microservices, impact the platform's performance, scalability, and maintainability. If you missed that video, no worries. You can find the entire playlist linked in the video description below. In this video, we're going to dive into an important concept for distributed systems, the CAP Theorem. Now, if you're new to this, don't worry. This theorem is all about understanding the trade-offs we face when building distributed systems. So, the CAP Theorem essentially says we can only guarantee 2 out of 3 things at the same time: consistency, availability, and partition tolerance. Let's break this down. Consistency means every read receives the latest write. Think of it as everyone always being on the same page. And availability means every request gets a response, even if it's not the latest one. While partition tolerance means the system keeps working even when parts of it can't communicate due to network issues. In a social media platform, let's explore how we decide which 2 of these properties to prioritize in different scenarios. Now, imagine chatting with a friend in real time. Here, we flip the priorities to consistency and partition tolerance. The system ensures your messages are synced and accurate, even if network issues cause delays elsewhere. The trade-off? Availability. If there's a network problem, the app might delay delivering some messages, but that's better than risking inconsistent conversations. Another scenario is your news feed. Here, we prioritize availability and partition tolerance. Why? Because users expect to scroll and interact with their feed without interruptions, even if the data isn't perfectly up to date. The trade-off? Consistency. It's okay if a post or a like takes a little while to show up. The smooth experience is what matters most. How about when you update your profile picture or bio? Consistency is key here, so we again prioritize consistency and partition tolerance. Your changes need to reflect accurately across all devices, even if it means temporarily losing access to the feature during network hiccups. The trade-off? Availability. It's acceptable for the system to hold off on certain updates if it means keeping your profile accurate. Finally, let's talk about notifications, those alerts for likes, comments, and more. Here, availability and partition tolerance take the lead. Notifications need to be accessible, even if they're a bit delayed or slightly out of sync. The trade-off? Consistency. Users won't mind if a notification shows up a bit late as long as they can keep engaging with the platform. So, for a social media platform, the general approach would be to prioritize availability and partition tolerance in most components, with eventual consistency where it makes sense. Here's how this looks in practice: news feed, availability and partition tolerance, with eventual consistency for likes and shares; real-time messaging, consistency and partition tolerance, so messages are always accurate; user profile updates, consistency and partition tolerance, ensuring updates are reliable; notifications, availability and partition tolerance, even if there's a slight delay in accuracy. By thoughtfully prioritizing these trade-offs, you can design a system that delivers the right user experience for every feature. And that wraps up this step in the system design of a social media platform. We've covered the CAP Theorem considerations for building a social media platform. Remember, if you want a deeper dive into this step, or want to explore all the other steps in detail, just head over to www.systemdesignframework.com. It's all there. And it's completely free. In the next video, we'll take things further and explore the next step in designing a social media platform. Trust me, you don't want to miss it. Hit that subscribe button and turn on notifications, so you're the first to know when it's live. See you there.